My name is Efrain Lopez, and I will present my work on assignment 1, a 4-dimensional KD3 for spatial data structures in spring 2023. And I reference the pseudocode in Wikipedia in this link. Okay, so here I load my libraries, which is nothing crazy. And then I load the data, I mount the Google Drive, and I save the CSV file data in a pandas data frame here. I look at the data frame and I see that there is this ST or state column, which is not required for the assignment. So I drop it and then I check it's gone. So it's gone. We only need these 4 discriminators. Then I convert the data frame into a list. I check the list and I can see all the cities and then the number of cities here. Okay, so question 1, insert all points into a 4D tree. So to do this, here I have all these functions, and I have k means the number of dimensions, which is 4, and height is a variable to track the height of the tree. This is a class to create node objects, and the main function is this one, insert main, where I use a recursive function to insert all the nodes. And I also keep track of the height here. And yes, and this is a function to compare points. Search, a function to search nodes. And yep, so basically the most important function here is insert main to create the tree. This is the main function where I build the tree, and I save the tree in this root object. And here I show the height. So what is the height of your KD3? It's 31. What is the minimum height of the KD3? According to what I found, it should be log base to n, where n is the number of points in the dataset. So here I do the calculation and I round up, so that is integer 12. How close is the minimum height to the height you report? Well, it's not close really. It's 19 numbers off. How would you go to construct your KD3 that has minimum height? To construct this tree, we have to do a balanced KD3, which I didn't do here, but that will be the solution. Okay, question 2 is report the points which fall within a specified rectangular winder by the following ranges. Okay, so we have to take into account these 4 range discriminators. So to do this, I create this range search main function, which has the root of the tree, the minimum point, the max point, and the depth. So this function is also recursive. So for example, here you can see it's being called again in the left and right parts of the tree. And I also handle this non-type in Python, which is null in the assignment. And yeah, so here I call the function search range, and the 0 is the height, which is always 0 at the beginning. Anyway, so question 2.1, report the number of cities and list all the cities in this range. So here's the range, and this is the number of cities, and this is the list of all the cities here. So it's a lot of them. Question 2.2 is the same thing, but using this range. So here is the range, and it's 98 cities, and this is the city, all the cities in the list. Question 2.3 is the same, but using this range. And here's the range, and it results in 12 cities, which I see is cities very close to Corpus Christi, like Galveston, Georgetown. And that is the end of my assignment. Thank you for watching this video.